Okay, let's start the class. Recently, the major thing we are learning is the triangle congruency. We know that we have full theorem. We have SSS, and then SAS, and AAS, and ASA to prove two triangles to be congruent. But students always worry about the names of the theorem. So today we will use this full worksheet to go through all those theorem names so that you will not forget. Let's see this first one here. If you have, look at this. If you have a line segment, say this guy is a CD, and they say lowercase p represent a line. So this p bisect CD at point E. So this p bisect this CD. That means these two parts equal. If these two parts equal, you will see this guy was bisected by this line. People feel confused. People think bisect means this guy is 90 degrees. Not really. You can see this line bisect this line segment as long as these two parts equal. If this line makes these two pieces equal at the same time it's 90 degrees, you will call this line as a perpendicular bisector. You can bisect without being perpendicular. You can bisect and also perpendicular. So this guy, definitely you can see this guy bisect this. This is called definition of second bisector. We also see the angle bisector. If you see these two angles equal, you will see this line is the angle bisector of this. But this line makes these two pieces equal. That's called second bisector. Okay? So please write down here. If say, oh, this P bisect this line segment, you will see definition of second bisector. And then you will see CE and ED is congruent. So this is because of the definition of second bisector. I have already always uploaded the notes. You need to print out the blank one and fill in the blanks during my class. And then let's see the number 2. Here, I didn't say these two guys equal. I haven't marked these two equal. So the thing you want to write down based on this is saying this angle QPT is equals to angle QPS plus angle SPT. You cannot write down this directly. You have to write down something called addition postulate. Just like the two guys here, you call this angle pair postulate, saying these two angles is supplementary. But here you need to say these two guys summation together equals this. You want to say this is angle addition postulate. And next one, this thing, we use this one so often. If you say B is the midpoint of AC, you will say AB equals BC, but you have to write down this midpoint definition. Okay, so this is the thing we need to remember to get the full points. So far, any question? So let's go here. Let me call. I already say this. So let's see Haiti. Let's give a try.
Hello.
Okay. So what's the theorem names for you to put over here?
Definition of segment bisector.
Very good. How about this thing? This is
angle addition postulate.
Yes, angle addition postulate. Excellent. And then for the thing here?
Definition of midpoint.
Very good. Very good. That's pretty good. Now, we will see this guy here. Let me call Steven. So number 4 over here.
Vertical pair.
This is vertical pair. This is not vertical pair. We just say vertical angle. Vertical angle.
My bad.
Yeah. No, you're fine. And then let's see this one. This one and this one.
Segment, addition, postulate.
Very good. That's it. You will see, wow, this thing is obvious, and you still have to write down those names. Yes, that's true. Yeah, it's tedious. And then here, if you see the angle is a right angle, the two sides of the angle is formed by AB and BC. So this angle, they say, oh, this is the right angle. And you want to give a conclusion of saying this BC and AB perpendicular. You want to see what? You want to see the definition of right angle. Yeah, so you want to write down the names here. We do this thing. When school start, you have the test. And when you want to fill the names, you will say, oh, I just leave a blank because I don't know the name. With this training, you will be able to remember the names so that you can fill it correct. Okay? Yeah. It's not too hard, but it needs your remembering this. Okay? You need to remember this. And then let's see this one here. This guy here. Sophie. Let's try 7, please.
It would be definition of supplementary angle.
Definition of supplementary angle. And then when they draw this, you have conclusion of that. What you should say here?
Linear pair postulate.
Yes, linear pair postulate. Very good. If I say this guy bisect this and say this two angle congruent, what should I say over here?
Definition of angle bisector.
Definition of angle bisector. Very good. So what we are doing over here, it's like we are making a Lego project. So here, so for example, we are trying to make like a frozen, okay? And we want to build up the frozen Lego, and we are building each small pieces, and then we will put them together. For the real proof questions, we need to put those parts together, and this is the foundation for us, okay? You have to show this kind of work. And then 10, 11, 12. When you see the two lines is perpendicular to each other, you will say, oh, this angle is a right angle. If you go from this direction, you will see the definition of right angle, just like what we are seeing over here. If you starting from right angle, you see that two sides perpendicular. You see definition of right angle. But if you are starting from the two lines perpendicular, you want to see the angle to be a right angle. You want to see perpendicular lines form right angle. Okay, this is the theorem names you want to write down. And next, over here, you see angle A and angle B are both right angles. So when you do the triangle congruency proof, you want to say the two angles are congruent. You don't just want to say, oh, these two angles congruent. You want to say something, say right angles are all congruent or right angles are congruent, to put this on the side. If it's two-way columns proof, you should list this in the reasons column, okay? And for this guy here, when you have two angles summation as 90 degrees, two angles summation at 90 degrees, these two angles will be called complementary angles. If two angles summation is 180 degrees, you will call these two angles to be supplementary. So the guy here, this is called the definition of complementary angles. A definition of complementary angles. This is also important. You know, this kind of question happens each year in the standard test called SAT. This kind of question happens each year in the standard test. So when this is part 1 geometry, we are learning the from the starting the points, the line segment, the angles, and then we will have triangles. After we learn the triangles, we have the quadrilaterals. And after we do the quadrilaterals, we know, if the two opposite sides parallel, we will call this a parallelogram. If this parallelogram, one of the angle is 90 degrees, then this two is supplementary. So everybody will become a 90 degree. It becomes a right angle. If the two sides, neighbor sides equal, the parallelogram becomes to a rhombus. If you are both a rhombus and you are also a rectangle, it becomes a square. Okay, that's so far what we have learned. And we do the triangle proof. After we finish this basic part, in the second part of geometry, we will learn the things called basic trigonometries. In the basic trigonometries, we always deal with right angles. So you have this. I think most of you, also some of you, heard this about something called sine, cosine. So for example, over here, this is a triangle ABC. We usually use the uppercase to stand for the angle, and we use the lowercase to stand for the side. So you can have this guy A, and you can have this guy B. The opposite side of capital B is lowercase b. The capital side C will towards to lowercase c. So I like to introduce a little bit. Definition, something called a sine. This is not called a sin. This is what Greek people designed called a trigonometry. It have helped us to solve a lot of hard navigation questions. See, so before people have a computer, long time ago, when you want to be a pilot or a captain, you had to master geometry and trigonometries. Let's introduce a little bit over here. This angle is capital A. This side is lowercase a. You have sine A equals to lowercase a over c. This is called opposite over hypotenuse. Okay, opposite over hypotenuse. And there's another thing called a cosine. The cosine is called, so guy angle cosine value is called the adjacent over the hypotenuse. In the right triangle, the longest side is always called hypotenuse. You can see HYP is called hypotenuse. For A, your opposite is lowercase a. For A angle, your adjacent is B. For the angle B, your opposite is lowercase b. For B, your adjacent is lowercase a. So cosine A, you have the definition of, let me call Jeffrey. Just now, I say sine A is opposite over hypotenuse, but cosine A is adjacent over hypotenuse. So cosine A is who over who?
Wait, can you say that again?
Cosine A is defined by this angle's adjacent, which is this side, divided by the hypotenuse, which is the longest side.
B over C?
Yes, so cosine A is B over C. Now, let me give you one more question. If you say sine B, this time sine B will be who?
B would be B over C.
Sine B is opposite, which is B over C. And then cosine B equals,
Is A over C.
cosine B is A over C. Now we have this listed correctly. Next, Jeffrey, did you notice that this guy equals this guy?
Yeah.
This guy equals this guy.
Yeah.
And also, look at the things we have over here. This is a right angle. the three angle summation is how much?
70.
All this together equals 180 degree, right? Triangle interior angle summation is 180, correct?
Yes.
If this is 90, these two plus together will be
90.
90. So that thing is like, for example, you have these two angle. If this two angle summation is 90 degree, this sine equals the other's cosine. So these two equal. And this two equal. Oh, so this is those typical ICT, PSCT questions. Some students is going to be 8th grade this year. Some student is going to be 9th grade this year. So I believe if you are a student of 41 ISD, October 2nd week, Saturday, is the day for the PSAT. So all of you guys, you probably take this test on the 2nd Saturday of October. They will have this kind of question. So I want to tell you guys, since we are learning right here, let's take a look at this so that during the test, when you see this question, you can do it, get a perfect score. Then you will have those college readiness percentage moving higher, okay? Your parents and you will be happy when you see a percent readiness for colleges towards those 90% above. Everybody will be happy. So the thing is here, when two angles together is 90 degrees, they call the complementary angles. If two angles are complementary, then the sine and the other guy's cosine will equal. And this guy cosine and the other guy's sine will equal. So keep in mind of this. So I say this one more time. If angle A, angle B, complementary. Write down this all. I don't see some students writing down notes. This is something really important. If angle A and angle B complementary, then sine A is going to equals to cosine B. And cosine A is equals to sine B. Okay? That's what's going on. Please write down these notes. If this thing right now kind of like too hard for you, you write down. And then after we finish geometry, the first part, we do the second part. You will say, oh, I understand what you were teaching us at that time. Okay? Write down this. One day we will revisit these places. Okay? Next, if you see something new, you have the guy here. They mark a H. They didn't put this point here. So the H is the midpoint of this line. And then you say, oh, you are repeating. Yeah, the worksheet have something repeating. So to check if you truly remember the correct theorem name. So here, you see the H is the midpoint of this line. So you will say, oh, CH is congruent to HS. This is because definition of midpoint. Yeah. We see this thing before. The two lines, if the two line segments are congruent, then you will see these two guys equal. So you might wonder, what's the difference between writing down this and writing down that? The definition of congruent is saying, if you move this guy to here, if these two guys are exactly identical, you will see these two guys are congruent. So if I do here, if these two lines are identical, I see this congruent. But when I say these two without the top one, without the top bar over there, if I say these two equal, it's saying these two guys' lengths equal. They're saying these two guys' lengths equal. Okay? For the angle, you can see this angle is a right angle. But you cannot say this angle is 90 degree. You don't say angle 1 is 90 degree. You say the measurement of angle 1 is 90 degree. You say angle 1 is right angle. You don't say this guy is right angle. This guy equals 90 degree. You say angle 1 is a right angle. Okay? Yeah. You want to have the correct habit at the beginning of learning the geometry. For these three guys, any question? This is easy to understand, right? Next, look at this. If I delete that, let's see here. Timothy, when you have this kind of graph, what do you want to say? Conclusion saying these two equal. And then what you should say? Because of what?
Because
Definition of what? See this guy
bisect.
You say bisect or you say something else in front?
I said bisect.
You say, you don't say bisect, you say definition of angle bisector, right?
Yeah.
Yeah. And how about this? You say angle 2 congruent angle 3 because
It's vertical.
vertical angle. And then for here, what do you write down? What you should say?
Is it the definition of supplementary?
Yes. You know, when we do this small piece, so that when you do the triangle congruency proof, when you see this kind of graph, if they give you this condition, now after this training, you will immediately figure out the next extra work you want to show on your flowchart proof or two-way column proof is going to write down these two angles congruent. Okay? All right? This is the training for help you do the proof question. For geometry, the calculation question is never a big trouble. The proof part is a trouble for most of the students. That's why we do this kind of basic trainings. Now look at here. Let's see this guy, Annie. Look at this. When you have the graph like this, you will say, oh, angle 5 and angle 8 are supplementary. What's the theorem names for this?
Linear pair postulate.
Excellent. When I say this one is a right angle, I will say these two lines perpendicular. What should I say?
Perpendicular lines form right angle.
If we are doing that direction, we say that. If we are doing this direction, we can say
right angles are from perpendicular lines.
yes, we can say that. And how about this one? Two here?
We can say definition of complementary angle.
Very good. And just now, we also have something saying A and B. This is 90 degree. So sine A should equals to what?
A over C.
So this is A over C. Did you notice that cosine B is who? Cosine B is adjacent over the hypotenuse. This guy adjacent is A, right? Yes. So you will say, oh, sine A is equals cosine B. Okay? When you see the two angle summation equals to 90 degree, you immediately say, oh, this guy's sine equals the other guy's cosine. Okay? All right. Now we have drew this. I'm going to delete this thing. I want you guys, let's see this. So boys, yeah, we have 3 boys, right? Yeah, we have 3 boys. So boys, I want you guys do the top 3. And then the girls do the bottom 3. Draw your graph and write down your theorem name and put your conclusions on your papers. Boys do all these 3. girls do all
Wait,
this.
do we send it to you?
Yeah, the due date, send me picture, please. Good job, Jeffrey. That's right. I wish you could write down a little bit neat, okay? Very good, Steve. Everything is perfect. Very good, Sophie. I really like your work all the time. As a student, please do for boys, you do these 3 questions. For girls, you do these 3 questions. Yeah, I prefer that you can do me on the paper so that I can see your work, because I do like that you can draw the figures also. For geometry part 1, we have to do the 3D geometry. In part 2, we will learn the 3D geometry. So drawing 2D is the basic foundation. Please use a ruler, pencil, erasers to draw your figures. Okay? Yeah. Draw things nicely. Yeah. This is something that not to be born. You don't get this training, you don't draw this nicely. Okay? Next one, let's go ahead to the next second one. So in this graph, you have the BE cross with AD, and you have a line OC, like this direction. So for this guy here, they said, okay, AO plus OD equals to AD. If they have this, that's going to be a typical called a segment addition postulate. So you notice that when you want to say one part plus the second part equals the whole thing, you don't say, oh, this is obvious. If the guy here is segment, you just put a segment addition postulate. And if you say the angle here, say angle AOB, this angle plus angle BOC equals to angle AOC. If you have this guy, you don't just say, oh, it's of course for sure. You want to say, write down something called angle addition postulate. And for the vertical, everybody remember this. As long as this line cross with this line, this is going to be a typical vertical angle. You write down those guys congruent, one step. This guy is asking for the same thing we are looking in the worksheet 1. So here, angle COE, this guy is right angle. When you have this guy right angle, you will see the line CO. The line CO is perpendicular to CE. So you will see right angles from perpendicular lines. If you see this guy go that direction, you will see perpendicular lines form right angles. Next one here, you see this OC. You see this OC bisect BOD. So with this training, when during the proof question, you see this kind of graph. If I tell you this thing bisect this angle, you will immediately say, oh, this angle 2 is congruent to angle 3, okay? And you will write down, this is the because definition of angle bisector. And then the last one here is repeating. Your OB here is perpendicular to OD. Then you will say, oh, this is the right angle because you see perpendicular lines form right angles, okay? You from here, you see perpendicular forms right angles. You come here, the perpendicular is concluded, you will see right angles come from perpendicular lines, okay? And next one over here, this guy, we have this basic training so that you will know what you can write during the proof questions. So the guy here is saying the Mn is congruent to Np. If Mn congruent to Np, you will have Mn equals Np. You will write down definition of congruent segment. So what kind of proof question do you need this? The very beginning of geometry proof, they like to ask you those line, if this is a midpoint or the two segment lines equal, they like to ask this kind of question at the very beginning. So this is those things you need to include in your very beginning of geometry proof questions. This thing also, if they say, you want to pay attention, MP bisect ST. So that piece equals that piece. But if you say TS bisect MP, you will say that piece equal, okay? But if you say this line bisect this angle, then you will have two angles congruent as the conclusion. Say this guy bisect MTP, like this line bisect this angle MTP. You will have angle MTN congruent to angle NTP. And you write down this is because definition of angle bisector. Okay? All right. So this thing are kind of like straightforward, very easy. The only thing is if they have the line congruent, you want to give conclusion saying that two segment lengths equal. If they say this guy bisects this, then you will write down that two individual line segment equal. Or you can also say this guy is congruent. If they say that line bisects the angle, you have that two angle congruent. So this is a basic thing. Number 2 is not too much. Let's do the the guy we did long time ago for those angle relationship. So we want to do sometimes we use the original statement, sometimes we use the converse. So I want to talk about something of the original statement, and then the converse, and then the inverse, and then the contrapositive. So let's do some example saying, what are those four statement means? So let me show here. So Angela, let's go ahead and do this practice. For the original statement, so we can make something say, if it is raining. Angela, if it is raining, then Angela will not go to the mall. Okay? Angela, so this is called the original statement. Write down this. This is something important. We want to truly understand this part. So original statement is from A to B. Then converse, you will just put B first, then you put A. So Angela, let's change this statement to be the converse. Go ahead, please.
If Angela does not go to the mall, then it is raining.
If Angela not going to the mall, you just switch this, right?
Yes.
So you put here. The converse is switch A and B. So it's if Angela does not go to the mall, then it is raining. Make sense?
Yes.
This is called original. This is called converse. So the original is, say, from A to B. If you want to get the converse, you will just put B, then to A. Okay? Next one is the inverse. Who is the inverse? The inverse is this shape. The inverse is from the A, you change to not A. From the B, you to not B. Make sense?
Yes.
So let's change. How do we change this to that so that it's not A to not B?
If it is not raining, then Angela will go to the mall.
Okay. So we will do over here. If it is not raining, then Angela will go to the mall. Still A in front, but change not A. B is at the end, but make not B. This is not means Angela will go to the mall. Okay. Last one. This is called the contrapositive. The contrapositive is actually do this. You do B and then you do A. And you do not B and not A. So the contrapositive is saying you do not B. Then you go to not A. Angela, go ahead. Let's try this guy to the contrapositive.
If Angela goes to the mall, then it is not raining.
So you want to do that guy, yeah, first. So if Angela go to the mall, so we are going to change this guy. And this is the converse. And I want to make this guy to be not. So not means yes. So if Angela go to the mall, then it is not raining. Okay?
Yes.
Yeah. This is called original. This second is called converse. The third one is inverse. The contrapositive is not B and not A. The interesting thing is this. Look at here. The original one, if the original one is true, say, if it is raining, then Angela will not go to the mall. If this is a true statement, then the contrapositive is also a true statement. Why? Because look at here. If Angela go to the mall, then if you say, no, I want to say it is raining. But look at here. If you want to choose it is raining, then if it is raining, Angela will not go to the mall. Angela go to the mall, Angela not go to the mall. These two are not going to be exist at the same time, right, Angela? You will
Yes.
not be able to appear in the mall and not at the mall at the same time. That's impossible. So the original statement and the contrapositive are equivalent statement. So write down these notes. Go ahead. I want all the girls and boys make your own examples. Say something else. If it is what, then what? And then do your own version of the original statement, converse statement, inverse statement, and contrapositive statement. Write down very neat on your paper so that I'm able to read and tell if your example is correct or not. Go ahead, please.
He sent it to you.
Yes, please. Timothy, pretty good. Your original statement, your converse, your inverse are all correct. Double check your contrapositive.
Oh, okay.
Yeah, that's the only one you want to fix. You will change the not B to not A. Okay?
Yeah, I see. Yeah.
Yeah. Yeah, good job, Annie. Yeah, your full statement are all correct. That's pretty good example. Good job, Jeffrey. You know, it's very interesting. All the boys and girls are talking about eating, hungry, eating. You guys are hungry? You guys haven't eaten lunch? That's why you guys all write down about food, hungry?
No, it's just the easiest thing I could think of.
Okay, that's interesting. I saw some people you write down say, if I get a math grade of 100, my mom will buy me an iPhone or iPad. Nobody gives that example. Yeah, good job, Angela. Other student, please send me these 4 examples. Yes, Sophie, thank you. Is a converse statement true for your mom? Is that a true statement for the converse? That's interesting. Thank you, Sophie. Good job, Stephen. You give me the example, first example without hungry or not hungry, food or not food. Thank you, Stephen. That's a good example. Yeah, good job, Haiti. That's good. That's good. All right. So when we see this thing, original one and the converse one, when we come back to see long time ago, look at this. If we see line L parallel to line M, then angle 1 and angle 2 are supplementary. If we say, oh, this is same side interior angle. If we say, oh, angle 1, angle 2 are supplementary, then we say L and M parallel. We will see what? We will see same side interior angle, but we put the converse. Did you guys see? That's the reason we need to put the converse here, because we are switching A and B, correct? The A and B was switched. That's why we say this converse. Make sense, everybody? Yeah, that's the reason we put the converse, okay? Yeah. So now let's look at here. Let me call student. We want to do this question very carefully. Stephen, let's see here. I have line S and T parallel. What conclusion I want to say?
Alternate exterior angle.
So angle 5 and angle 6 are congruent because of exterior
Alternate.
angle. Alternate, yes, very good. And then how about this one? A parallel to B, what do we say?
Oh, alternate interior.
So you will say angle 2 is congruent to angle 3, correct?
Yeah.
Yeah, and you want to give the conclusion also, okay? Yeah. And then number 3, go ahead.
Vertical angle.
The 1 and 2, these are vertical angles. You want to say angle 1 congruent to angle 2, right?
Yeah.
Okay, that's pretty good. Now let's look at the second row. Let's see, Jeffrey. Number 4, please.
Line K and line M parallel.
Because?
Definition of supplementary angle.
Hold on. if I have if I have line K parallel to M, as you see, angle 3 and angle 4 are supplementary. It's because of the same side interior angle. But if I say angle 3 and angle 4 supplementary, then my conclusion saying K parallel to M is because of same side interior angle converse. That's the thing I want you to put over here. That makes sense? Jeffrey, does that make sense?
Yes.
Okay. Now look at here. The OM parallel to AN. If OM parallel to AN, what do you say?
Angle 1 equals angle 2.
Angle 1 congruent angle 2 because?
Alternate interior angle postulate.
Very good. No, don't say postulate. That's a theorem. Postulate is always, those guys are called postulate. Here is the theorem, okay?
Okay.
And over here, angle 3 is congruent to angle 4. What conclusion you want to have?
Line C and line D parallel.
So because?
Corresponding angle converse.
Thank you. That makes sense? Yeah, we have to make sure we put the converse, okay? All right. Next one, Sophie, let's do this row, please. Look at here, Sophie.
Yeah. Angle 2. Oh wait.
Yes, angle 2 congruent to angle 3.
Yeah.
Angle 2 congruent angle 3, you have what?
Alternate exterior angle.
And your conclusion is?
Measurement of angle 2.
Hold on. This guy is going to have conclusion for some lines parallel.
Oh, S is parallel to T.
This two.
G is parallel to H.
Yes. That makes sense.
Yeah.
These two guys saying these two lines parallel. If I have these two guys, you have these two lines parallel. Make sense?
Yeah.
Oh, these two give this two line parallel. It's because alternate exterior angle. Okay. Next one. S parallel to T.
Angle 2 is congruent to angle 5.
Angle 2 is congruent to angle 5. True. Because?
Alternate exterior angle.
Good. One more, please. Number 9.
Angle 4 and angle 5 are corresponding angles.
Yes. You have K. Hold on. Watch out. These two. Yeah, these two. Yeah, angle 4, angle 5, corresponding angle. Okay? Yeah. When you have just one pair of lines, having this easy. When you have multiple lines, we want to watch out carefully. Next one here. Katie, let's try this number 10. 3 and 2. We'll take conclusion you have. 3 and 2 congruent, and then?
So line C and line D are parallel
because
of
these two angles
definition of corresponding angles.
We are from these two angles congruent. You want to see these two lines parallel.
Oh,
and this
corresponding
guy,
angle converse.
Thank you. And next one, this ET and XA parallel. What conclusion you want to have here?
Angle 3 and angle 4 are congruent.
It's because
Alternate interior angle.
good. Last one over here. This angle 4 and angle 1 are supplementary. What conclusion you want to have?
Line A and line B are parallel.
It's because
Same side interior converse.
thank you. Very good. We want to see where is the position we want to put converse. Where is the position we don't put converse. Okay? Yeah. Because we do this training now, we should understand the reasons. Now over here, some question is repeating. Let me call Timothy. Next one here. When you see this KU is bisect this angle, what conclusion you want to write down right here? You say this KU bisect this angle, so you want to say what conclusion right here? The guy bisect this angle is saying this makes this two piece equal. So who is congruent to who? Angle 1 congruent to angle 2, correct?
Yeah,
Because what?
because it's a pair, a bisect.
Definition of angle
A
bisector. Yeah, you missed this many times already. Next one here. AL bisect EG. AL bisect EG. So your conclusion is?
It's
This line bisects this segment. That means that P is congruent. Okay?
okay.
Because what?
Because it's
This is
Yeah.
called a segment bisector. Definition of segment bisector. This is the first question we did right here. That guy. Kind of remember? Not remember?
yeah,
Yes or no? No?
I do. No, wait, no. I do.
Like number 9? When you see this, you want to say what? You have this showing here, what you want to write down. You have this angle plus this angle equals this angle, correct?
Yeah.
This is called what?
Definition of supplementary.
I didn't show you this. This is called angle addition postulate. I don't know why the thing I teach you just now, you missed 3 of them. Okay, you can mute yourself. Next one here. Let's see. Annie, let's call here. Let's go ahead to this one.
So that would be the substitutive property.
Good. Substitute property. So we have which conclusion?
Measurement angle 1 plus measurement angle 3 is equal to measurement angle ABC.
Good. Very good. Next one.
That would be definition of midpoint.
So conclusion will be?
Line AM is congruent to line MB.
Good. Very good. Definition of midpoint. And then over here.
That would be definition of congruent segment.
You can see this guy is congruent to this. Okay? Yeah. That's pretty good. Or you can also say this. You can also say R is the midpoint. So you might feel curious. Sometimes you want to say this, sometimes you want to say this. Which one is correct? As long as your supporting reasons support this correctly, that's fine. Which one is counted as correct is going to be based on your context. Just like the English vocabulary, at different contexts, it has different meaning. So when you do the proof, it depends on which thing you want to prove. If you prove the triangle congruency and you ending up saying this two piece is congruent, your final question is to prove the R is the midpoint. Then this is the thing you are going to use. Okay? Yeah. Yeah. Okay. Now, let's see here. Let's see this one here. Let's call Angela. Look at here. This angle T is a right angle. What should we say?
Definition of right angle.
So conclusion should be?
Oh, P is 90 degrees.
Yeah. So you see measurement angle T is 90
Oh.
degree. Okay. Yeah.
Okay.
And then when you see two angles measurement is addition equals to 180, what do you say?
Supplementary
Yeah, you will say angle
measure-
3,
oh, yeah.
angle 7
are
are
supplementary.
supplementary. Yes, good. And that is because?
Definition of supplementary angle.
Angle, yes. And then when you have the two angles degree listed, the thing you will think about is going to put them plus, right?
Oh,
Yeah.
yes.
You just plus and make it equals to how much?
Equals to 20, wait, like
Yeah,
25
this,
plus 48.
yeah, which is 73 degree.
Oh, yeah,
Yeah.
73.
Yeah, so it's just the angle addition postulate. And the last one here, if you say two angles are complementary, you will see their measurement plus together is 90 degree. Okay? Yeah, that makes sense.
Yes.
So you might feel curious. You talk about the hard proof question, how hard it's going to be. So let me show you guys what kind of hard proof question we are going to see in the future. This is the fall semester, first 15 classes. So in the future, we are going to do those triangle similarities. Right after, so today's class is the drawing conclusions. We will list all those necessary theorems you need to keep in mind. And next class, we will immediately do the triangle similarity proof. For the triangle similarity proof, so you guys, you see, we will do something like this kind of thing. Yeah. Previously, doing two triangles congruent is either 3 lines or 4 lines or 5 lines. But when we come to triangle similarity proof, each proof question will be way more longer. And the thing we are doing today is helping everything we are going to do in the next 3 classes. Yeah. Everything we are doing today is going to help in our next 3 classes. So you have to remember all these things clearly without being confused. And next, let's keep calling student. This first 3, let's call Sophie. Look at this. You see this graph, you want to see what conclusion?
Angle A and angle B are supplementary.
Because it is
Definition of supplementary angle.
yes. Or you can just say you say angle A and angle B are supplementary definition of supplementary angle. And for this guy, immediately what we want to put over here.
Linear pair possible.
So the conclusion here is saying
Angle 2 and angle 4 are supplementary angles.
very good. And then if we see here, what should we say?
B is the midpoint of line AC because
Uh-huh.
definition of midpoint.
Uh-huh. Very good. Very good. And then let me call Steve. Steve, let's see here. So you have this. If angle C is a right angle, what conclusion you want to write down here?
Angle C equals 90 degrees.
We want to say measurement angle C is 90 degrees. Okay?
Up.
Yeah. And then for this guy here, what should we say?
HO
Uh-huh.
plus OT equals HT.
Very good. The reason here to be?
Segment additional postulate.
Very good. Thank you. Let's see this number 6.
It's angle D. Wait, yeah, angle D
Yes.
plus angle G.
You will see D and G are,
Complementary.
yes, because
Definition of complementary angles.
very good job. Yeah. See, boys can also do these things very neat. Very good. Next one. Haiti, let's try over this line. Go ahead, this one here. You want to say what?
IT.
Mm-hmm.
Okay. Line AB is perpendicular to line CD.
Mm-hmm.
So, perpendicular lines form a right angle.
Mhm.
So, angle 2 is 90 degrees.
Mm-hmm.
Line AB bisects line CD.
Mhm.
Mm.
This guy bisect this. This guy bisect means this guy is split into 2 equal pieces. Okay? So who is?
So
Mhm.
line segment DE is, what's the word?
It's
Congruent to line EC.
Good. The
The
reason is
segment.
because
Because of
definition of segment bisector, right?
Yes.
If you have the angle, that's called angle bisector. If this both are line segment, this is called the segment bisector.
Segment bisector.
Good. Number 9.
Angle KAT is a right angle.
Mm-hmm.
So
You will say this
the
guy and this
line-
guy.
So they're perpendicular.
Yes. Because
perpendicular lines form a right angle.
yes, exactly. Very good. You might say, hey, you might feel curious. Why do I ask you, force your guys to do this? So we do the proof like we are doing the puzzles, right? You were given the given conditions. So those are the edge for you to start with the puzzle. So you have a big puzzle to figure out. But those given conditions are those several edge puzzles you can put immediately. But after laying out those given conditions on the very first step, you want to keep it going down. So you going down by what? By this. If you're given saying that thing, you will push this down. Say, oh, that angle is a right angle. Oh, this gives this 2 congruent. Oh, this is saying these 2 lines are perpendicular. So you found the given, which is the edge of the puzzle. You push one more step. That's what we are doing right here. After you push down those things, and those things might be connected to something to help you reach the goal of the triangles to be congruent by satisfying those SSS or SAS or ASA or AAS. That's the reason we are doing right here. Because I know some students don't like the proof question. That's why we are doing this basic training to help you guys. So Timothy, let me see this time if you can do better. This guy. You unmute yourself.
Yeah.
This guy. You don't know what to do, you draw this first. You say, oh, TAU. And then this is AM. Based on this, you need to be able to draw it. So your conclusion will be what?
Your conclusion will be
Okay, you take
oh
your
the
time.
conclusion is angle TAM is congruent to angle MAU.
Thank you. Because of what?
The definition of angle.
Bisector. Okay.
Bisector.
Okay. And then go. Here.
The second one.
Yeah. If this two angle is congruent, you want to say what conclusion? You want to say this guy is who? This guy is what?
GI.
Yes. This is a angle bisector, correct?
Yeah.
And last one here. When you see
That's a
this,
vertical angle.
yes. So you see angle 6 congruent to angle 7 is because of vertical angle. Okay? That makes sense now? Yeah. All right. So we have this full drawing conclusions worksheet. So doing this to make you ready for our future triangle similarities. So here, look. This is a very hard proof questions that we are going to learn. This guy here, I want to show you guys. This is a difficult questions. The given condition is saying angle 1 is congruent to angle 2. Angle 1 congruent to angle 2 is a given condition. And the conclusion is saying you want to prove that AB divided by AC, AB divided by AC is congruent to BD divided by CD. This is called angle bisector theorem. Angle bisect theorem. If you have a line bisect this angle, then this part length divided by this part length is going to equals this guy divided by this guy. It's not easy to prove this one. Definitely not. It's a hard question. I show you guys in the future if we do those proof questions, how hard the proof question could look like. So here, let me call Jeffrey.
Yes.
If we want to prove this guy over this guy equals this guy over this guy, it's not easy. So we are going to draw a line like this. When we draw this line, we will draw this pink line parallel to this blue line. Okay?
Okay.
Yeah. And then we will start to see. Look, we start from the left. We say given. If we draw this thing, this becomes our given. So we will given CE parallel to AB. Okay?
Okay.
If this parallel to this, 1 congruent to E, because
Alternate
interior angle. Okay, so 1 is congruent to E. Now 1 congruent to E. And I say this is the angle bisector, so angle 1 is congruent to angle 2, correct?
Yes.
Because definition of angle bisector. 1 is congruent to E. 1 is congruent to 2. So 2 is congruent to E, correct?
Yeah.
This is because of transitive property, right? After this transitive property, we get E congruent to 2. If these two angles congruent, remember like in your 6th grade, you might learn something about the isosceles triangle. The definition of isosceles triangle is saying the two base angle equal, right? So if this two base angle equal, this is a isosceles triangle.
Yeah.
If you have an isosceles triangle, you will have these two sides also equal, right?
Yeah.
So you have AC is congruent to CE. So we prove that part equals that part. So that guy is congruent to that guy. Now, we finish this left proof. Now we are going to do this right part. So Stephen, let's see here. During triangle congruency, what's the full theorem? Tell me, please.
The theorems we did last on Wednesday.
Yeah.
Uh
SSS. And?
Side, and then there's side, angle side. And then there's
angle side angle, right?
Yeah.
And angle side, correct?
Yeah.
So this fold to prove two triangles are congruent. And then right now we are learning something called new. It's called a triangle similar. Did I mention this before? These two triangles, do you think they are congruent?
Yeah.
No.
I mean,
they are not. Their shape are the same, but their lengths are different. So these two are not called congruent. The lengths are not congruent. Only the angles are corresponding equal. In this case, we no longer call it congruent. We call these two triangles to be similar. Make sense? You have a small angle triangle, you have a big triangle. The smaller one and the big one is called similar. Can you accept this?
Yeah.
When the two triangles, the shape or the angles are identical, but the sides are different, you call these two triangles a similar triangle. And if these two, look at this, you have this angle equals this angle, right? Did we already prove this right here? Yeah. This guy parallel to this, you have one and congruent to E. Do you have these two guys congruent also?
Yeah.
Vertical angle. Do you have this congruent to this?
Yes.
Because?
The alternate angles.
Did you notice that? This equal, that equal, that equal. So these two triangles is similar triangle. Make sense?
Yes.
Oh, the interesting things about similar triangle, the corresponding side ratio equal. So the small guy over here, this guy's opposite side is this. This same angle opposite side is this. So the AB over CE is going to equals to BD over CD. Does this make sense to you?
Yeah.
This part over this part equals this part over this part. So you have proved. Look at here. AB divided by CE equals to BD divided by CD. Do you buy this? This divided by this equals this divided by this. So far, so good?
Yes.
Next. Any? We prove that P is equal. And we prove this equation is correct. Now we are going to replace CE and EC are the same. So CE will be replaced by AC. So the final conclusion will be AB over AC equals to BD over CD. So we get that thing finally by substitutive property. Does this make sense?
Yes.
Okay. Is this a hard question?
Yes.
This is a hard question. This belongs to those very hard questions for geometry proof. But the good thing is, I don't think your school will give you this kind of question for your test. If this question is asked in the test, this is those bonus question, okay? This is for students who want to be higher than 100, say, I want to get a 105 for my geometry. Then you want to do this. But this is showing how hard the proof question is like. So we need all those things to list it here to be able to reach to this final answer, okay? That's bring us the topic of triangle similarity. So let's talk about if you want to prove two triangles to be similar, what kind of conditions you want to reach. These are the triangle congruency, but for triangle similar, you are using different things. You are using called AA. Look at this. If you have two triangles, draw this, write down the name. This is important thing which will support all our worksheet for next class. Go ahead, draw this on your paper. Draw this. This is called AA. It's called AA. Angle, okay? Angle theorem. What does angle theorem means? If you have these two angle congruent, if you have these two angle congruent, three angle together is 180, so this guy is going to be congruent. These two triangles, their lengths not congruent, but the three angles corresponding to each other, corresponding equal to the other. So these two triangles called similar triangles, okay? Similar triangles. That's called AA, huh? Write down the AA as your first one. Second one, when I don't give you any of the angle information, but I write down the three angles lengths. This is a Pythagorean theorem, yeah? 3, 4, 5. You know what? They have the guys marked on the wrong directions. Let me fix it. The hypotenuse is 5. I put this on the wrong spot. This is 4. This is 5. Okay? The two triangles, this guy is double of this. The shortest one is double the shortest one. The longest one is double the longest one. The middle one is double the middle one. You call this called SSS. It's say three side ratios are equal. This is called SSS. Write down this one. The first one is called AA. The second one is called SSS. And the last one is called SAS. If I tell you this guy divided by this guy is 2, this guy divided by this guy is 2. At the same time, I see these two angles are congruent. I will see these two triangles to be similar. This is called a side, angle, side, side, angle, side, side, angle, side. Okay, side, angle, side, side, angle, side. Okay. So for to prove two triangles to be similar, you only need these three. That's the only three theorem names called AA, SSS, or SAS. Okay. Now, let's do this summary. If you say, oh, this question is really too hard for me, don't worry, your school will not test you this in the real test. if this question appear, it's for those bonus question, which means you already reach 100, you want to get 105. Now, I want you guys give me a quick summary and send me your work. List the 4 theorems to prove triangle to be congruent. Okay? So give me the 1, 2, 3, 4. If you want to prove the 2 triangles to be congruent, list this and draw it quickly. So for example, you want to see SSS, you want to draw something like this, showing that this is called SSS. Okay? Show me the graph with the correct names to prove 2 triangles to be congruent. And then show me the triangle similar, the 1, 2, 3. And what I show you first example, I want you to draw a big triangle and a small triangle. For the first one, I called AA. So given this 2 angle equal, given this angle equal, and then I call this is called AA. Go ahead, do your quick summary, send me your work. Let me see if you truly understand what we have learned so far. Yeah, so for this one, you want to say SAS. You want to write down, you need to show me your work saying AB over A prime B prime is equal. It's ratio, so you write down equal. Equals to BC over B prime C prime. You have these 2 ratio equal. Then at the same time, you have the angle between them congruent. If I don't tell you this, but I tell you this, that's not SAS. This called, if this ratio equals that ratio, but I tell you this angle equal, you cannot see these 2 triangles congruent, not at all. You have to make sure the angles is between these 2 lines. And then the last one, you will have all the 3 pair ratios equal. That's how you can see the 2 triangles are similar. Go ahead, quickly write down this summary, please. Okay. All right. Do this, show me your work, then you can leave. This is for triangle congruency. This is for triangle similar. Okay? Yeah. That's for today's class. I see you on Wednesday. We will still have class this Wednesday. If you miss a lot of class already, so on Wednesday night, let's see, you can join early to ask me for help, or you can stay late to ask me for help. Okay? See you on Wednesday. Send me your work of this page, please. Thank you.